Bending strain refers to the change in length of a structural element as a result of bending that occurs due to stress. When a beam is subjected to external stress, shear force, and also the bending moment that experienced by each part of the beam. Stress and force are simply familiar in terms of bending stress and bending moment. Thus, when an object is subjected to an external load at the cross-section, it will experience the bending stress. An alternate definition of bending stress is the sum of the section modulus and the bending moment. Transverse load will cause any cross-section of a beam to bend. The bending stress formula is used to calculate the bending stress in a beam. Then the formula is bending stress equal to my divided by I, which is m is bending moment of the section passing through a point, y is a distance from NA, and I is moment of inertia of the section bending stress. For the problem signification, the problem is the material that being used is easy to decay over the time, so the load that can be bear will also decrease. The thickness of the hook is so average, this means that the hanger can be used for dry towel only. Then, if the towel is wet, the weight must be higher from the dry towel itself, so the hanger tip will broke because of overweight. So the thickness of the hanger may be the most important thing to consider in case people want to hang a cloth or towel. If you look closely, the tip of the hanger are very thin. This might break the tip when there is overload weight by the hanger. Thus, the clothes or towel may fall to the ground if the hanger breaks.
Assalamualaikum and hi. My name is Muhammad Imran Haziq and I will be explaining about the methodology. For the first part of methodology, we have the flow chart, which is the process on how our group works for this project. Firstly, we will do some background study to determine some problems, and then the problem identification will go on deep about how our project is relevant, and then we have the our group members will provide with a solution, and then providing the calculation for the original and the new design, and then modeling and testing. If we fail, we will go back to modeling, and if we manage to come with a good enough design, then our project will end.
Proposal design stage. First is define project goal. Next is identify risk. Next is parametric design. And lastly, analysis of design. Define project goal. Work together with the team to determine the objective and the result that is wanted for the project. Identify risk. Keep an eye out for anything that can delay the project completion. Parametric design. The team member will choose material for the product roughly at this phase. Analysis of design. This may be done by developing throughout project plan that include doing specific tasks and report. Proper solution. This problem found on the door hook with hanger can be solved accurately and correctly. The product will be placed on smooth surface of the door. The solution that we can make is redesigning the product by changing the measurement of the product. Other than that, to further increase the strength of the product, we will also increase the thickness. We will also consider the distance between the hook and the door surface. Material used: alloy steel. The material that we choose is alloy steel to replace the existing material, which is metal. We choose alloy steel because of its property that it has, with its strength, hardness, toughness, wear resistance, corrosion resistance, hardenability, and hot hardness. The main point here is the wear resistance and corrosion resistance. The wear resistance can help to gradually resist the deformation that will occur to the product. The same also applies to the corrosion resistance, which can help to slow down the corrosion that will occur to the product.
For the calculation part, we have the original and new design. For the original design, the first step we have to do is make the free body diagram and also inputting all the force and the dimensions. For the second step, we have to find the reaction force at A by using sum of Fy. And then at step 3, we have to cut the component into several parts and find the bending moment. For step 4, we can input all the distance into the formula of bending moment for part 1 and 2. And for step 5, we can input those values into the graph to determine which value has the highest amount, be it counterclockwise or clockwise. For the new design, we have to do roughly the same thing as the original. For the first step, we have to make the free body diagram and labeling all the forces and distances. For step 2, we have to find the reaction force at A by using sum of Fy. For step 3, we have to cut the component into several parts and find the bending moment individually. For step 4, we have to substitute the value of the distance into the formula of the moment. And with those values, we can input those into step 5, which is the graph. And we can determine the maximum bending moment, be it counterclockwise or clockwise.
This is the final design of our product that we created using SolidWorks software. The main difference that we can see here is the thickness of the product.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azhar Figur Muhammad Azlan. Matrix number is AA210794. I will present about conclusion. In conclusion, our group has successfully improved the design of door hanger with hook. This modification proved to be able to handle pressure higher than the weight of the garment. To prove it, the bending stress in the rod before modification is 0.8829 Nm. After modification, the bending stress become 0.588986 Nm. Therefore, the hanger with hook can withstand more weight, thus extending the life of the product. Furthermore, this longer lifespan will ultimately reduce maintenance costs in the long run. Thank you.